friends, this is Dr. Sivanagaraju, Associate Professor, Institute of Aeronautical Engineering. Today, we are going to discuss the analog communication subject. So, in this subject, the students is going to know what is communication, how that analog communication is done. So, these all concepts are going to discuss in this video. Okay. So, in this video, first we are going to discuss the introduction about that communication system and analog communication. Okay. So, first, what is a communication? Communication is the process of conveying or transferring messages from one point to another. Okay. So, here we're having the important blocks in this communication system. The first block is information source. That means we require some information. So what is the communication? The communication means transferring or conveying the information from one point to another. Simply you can call it as from source to destination. Okay. So the information is necessary. So it may be the information may be in analog form or in digital form. And another one is a transmitter block. So the transmitter duty is to transmit the signal. Why? The information or the message is in baseband. So then information signal you can call it as baseband signal. Baseband means originating the very low frequencies. That is, the baseband is a very low frequency. So this low frequency is changed to high frequency. That function is done in this transmitter. Okay. That means here the modulation is a basic function what is done in this transmitter. Another one is the channel. Why? Because in any communication system, the transmitter and receiver are separated at a distance. So this distance is covered by the channel. The channel may be a wireless or wide channel. Okay. But in this channel, the signal is distorted due to the noise. And the last block is a receiver. The receiver duty is to extract the original signal from what the transmitter is sent. Okay. So here the first block is transmitter. Before the transmitter having source. The source may be analog or digital. So what is the meaning of analog? Analog means the signal which continuously vary with respect to time, we can call as analog signal. Digital. Digital signal means here we convert the analog signal into discrete first and then encoding the discrete signal we get the digital signal. So anyone, either analog or digital, the signal is transmitted to the transmitter. So the transmitter would have having the transducer, amplifier, modulator, and some power amplifier, and finally having antenna. So the transmitter is a combination of electrical and electronic components. Why? The transducer which converts energy from one form to another. So basically we require an electrical form. So here the transducer which converts the signal into electrical form. And then the signal is going to amplify and then apply to the modulator. Here the modulation is done. So in the coming slides, we are going to discuss what is modulation. Okay. And after the modulator, again it is going to amplify and finally it gives to the antenna. So the antenna which radiates the signal into the space. And the channel, another one is channel. So what the channel? The channel is a communication link between the transmitter and receiver. It's having it's maybe a cable or optical fiber. So these come under wired connections, and wireless is a free space. Okay. Another one is a receiver. The receiver, which contains again an antenna. Why? The receiver duty is extract the signal from the space. That means the transmitter which sends the signal into the space, and again this is collected by the receiver by using an antenna. Okay, so the antenna is used for transmitting and receiving purposes. So it is a metallic structure. Antenna is a metallic structure. And another one is the amplifier. Why? The signal is travel for a long distance, so we are going to amplify first. That means we are going to strengthen the signal, then we are going to demodulate. So what done in the transmitter is the reverse operation is done in the receiver. In the transmitter we are going to modulate, so here we are going to demodulate, and finally apply to the transistor, and what you send the original signal is collected back from the receiver. So this is our analog signal. Analog, the signal in which both amplitude and time vary continuously, is called an analog signal. So example for this analog signal is speech or television signals. So we can see in this picture the sensor signal which is varying with respect to time. So we can take at time t equal to 0, the amplitude is 0. The time is going to increase. Again, at some instant, the amplitude is increased. Again, that according to time, the amplitude also vary. So we can call it as analog signal. So this is what you the extended block diagram of that analog communication system. So information source again: input transducer, transmitter, channel, receiver, and output transducer. So what we discussed earlierly here given briefly. Okay. So in this input transducer, which converts signal into electrical form, and this electrical form signal is applied to the transmitter. Again, the transmitter, the modulation is done. After modulated, the signal is sent to the channel. Again, the channel, the signal is going to distorted due to the noise, and finally we are going to collect the receiver. Finally, collect the signal at the receiver. At the receiver end, again having output transducer. So what input transducer done, the reverse operation is done in the output transducer. Okay. So now, what is modulation? Modulation is a process by which some characteristic of high frequency carrier signal is varied in accordance with the instantaneous value of the another signal, called modulating or message signal. So that means here some of the characteristic. Some. What is some characteristic means? Here already we shown that analog signal having 3 parameters. One is the amplitude, and time, and phase. So these are the important parameters of analog signal. One is amplitude, another one is the phase, and time we can universally take as a frequency. So generally we can take the 3 parameters for analog signal is amplitude, phase, and frequency. So in those 3 parameters, one characteristic is varied. If amplitude is varied in accordance with the instantaneous value of modulating signal, we can call it as amplitude modulation. If phase is varied in accordance with the instantaneous value of the message signal, we can call it as phase modulation. A frequency is varied in accordance with the instance value of the message signal. We can call as frequency modulation. So this will come in the next slides and next videos. So first, what is the need of modulation? Why? Why are we doing a modulation? So already we discussed baseband signals. The message we can call as simply as a baseband signal. That means original signal. If someone is, for example, someone is talking. So what is the frequency of the voice signal? So it must be in kilohertz. So this signal cannot transmit for long distance. We are going to modulate the signal and then transmit. Okay. So here in the modulation process, we require two signals. One is the message signal. So the message signal we can call as a baseband signal, and another one is a carrier signal. So this message signal is carried by another one that we can call as a carrier signal. So this carrier signal is a high frequency signal than the message signal. Okay. So the resultant, we are going to modulate those two. The result signal we can call as modulated signal. The resultant signal of the process of modulation is called modulated signal. This is a combination of modulating and carrier signal. Or simply we can say modulation is nothing but superimposing the message signal on a carrier signal we can call as modulation. Okay. So need for modulation. So why we are going to modulate? What are the advantages regarding this modulation? So first one is reduction in height of antenna. Reduction in height of antenna. Already we know that formula, that is C equal to F lambda, what is wavelength, which is equal to C by F. Generally the heights of the antenna is taken or must in lambda by 4. Lambda by 4. So here L is equal to lambda by 4. L equal to the length of the antenna, or the height of the antenna is lambda by 4. So we know that lambda is equal to C by F. So we're having 4F, C by 4F. That is the length of the antenna. For example, F is in kilohertz. I'm taking 10 kilohertz. F is 10 kilo. And C is velocity of light. We know the value is 3 into 10 power 8 meters. So here we're going to substitute 3 into 10 power 8 meters divided by 4 into 10 kilo. So what you got? This for these frequencies. So 3 into 10 power 4 divided by 4. So you can divide that one, get 7,500 meters. Not in hertz, it is in meters. 7,500 meters. So it means the length of the antenna, which is 7.5 kilometers. So is it practically possible? So that's why we need modulation. So now the F is increasing after modulation. It is in megahertz. Okay. So for example, again you take the same expression, that 3 into 10 power 8 divided by 4 into 1 mega, 10 power 6. So we can get 300 divided by 4. So we know 75 meters. Now it is reduced from kilometers to meters. So if you use modulation, you get a reduction in height of antenna. And the second one is increases the range of communication. Already discussed. The baseband signal cannot transmit for a long distance. Okay, if you modulate that baseband signal, it enters the passband, so it can transmit for long distance. So the range of communication is increases and allows the multiplexing of signals. So we can multiplex, we can combine more signals. Okay, and the fourth one is avoids the mixing of signals. We're not using modulation. More than one transmitter is transmitting the signal, so all are having that same band. They are going to mix it up, and again the receiver having a difficult to extract the original signal from different transmitted signals. So if you are using modulation, you can avoid the mixing of signals. So coming to the next slide. So multiplexing. So what is multiplexing? Multiplexing is the process of combining multiple signals into one signal shared over a single medium. Okay. If the analog signals are multiplexed, then it is called as analog multiplexing. If the digital signals are multiplexed, then it is called as digital multiplexing. Okay. Already we said the signals, the information may be analog or digital. Okay. So multiplexing was first developed in telephone system. So simply the multiplexing we can call as multiplexer or mux. That means the duty which performed multiplexing we can call as multiplexer or mux. And the reverse operation that is called as a demultiplexing we can call as simply demux. So here the figure which illustrates the concept of mux and demux. So here AND signals is given to the mux. So these are going to combine and transmitted on a single channel. Again in demux, which again divides those signals and apply to the end users. So what are the types of multiplexers? So multiplexers are here given two types. One is analog and one is digital. If you use analog signal, you can call it as analog multiplexer. So this analog having FDM, WDM. It is frequency division multiplexing. Simply you can call it as FDM. And WDM, wavelength division multiplexing. So these two multiplexing techniques come under the category of analog multiplexer. When it comes to digital, having TDM, time division multiplexing. Time division multiplexing, simply called as TDM. Again, this TDM is subclassified into synchronous TDM and asynchronous TDM. But in this analog communication, we're having only FDM. The syllabus we're having FDM. So this is actual picture of this FDM, frequency division multiplexing. We use different signals of the different frequencies is going to given to the mux. So the mux multiplexer is going to combine those signals and share into a single communication channel. Again in demux, the reverse operation, what was done in mux is reverse process is done demux. So in FDM, divides the bandwidth of the channel into several sub-channels. That means each sub-channel is allotted for a different signal frequency. That means in FDM means the separation of the signals in frequency. Okay. So what are the advantages? So it transmits multiple signals simultaneously, and in FDM the demodulation process is easy. And another advantage is it does not need synchronization between transmitter and receiver. Okay, so there is no synchronization required between the transmitter and receiver when using FDM. And what is the disadvantage? So disadvantage means it needs a large bandwidth connection channel. So it means it requires large bandwidth, more bandwidth is required. Okay, thank you. And what are the applications? So the applications of FDM. So FDM is used for FM and AM radio broadcasting, and it is also used in the first generation cellular telephones. And another application is television broadcasting. So these are the applications of FDM. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.